I hope everyone of you are aware that the full form of SQL or SQL is structured query language. It is called a structured query language because it will store the information in structured format. SQL will store the data in structured format. Structured format is nothing but of table format or tabular format. When it comes to this table format, table is an object which contains elements called rows and columns. Let us consider I have a table where I have few people information, where I am storing name of the person, their place and phone number. Let us consider I am storing information of two different people called Ram and Sam. Here, table is a combination of two different elements called rows and columns. When it comes to row is a place where we can store all the details of one particular person, object, action, or transaction. If we are storing any information, the information will be of some category or some object, some person, or something, right? If data is stored in any specified row, in that particular row, we will be able to find all the details of one particular person, object, action, or transaction. In row, we can store all details of one particular object, or from row, we can get all details of one particular object. When it comes to column is a place where we can store one detail of all the people. When it comes to column called name, from this particular column, I can get only one detail called name, but I will get names of all the people. When it comes to row will store all the details of one object. When it comes to column will store only one detail of all objects. In normal terminology, you can also consider as horizontal thing is called as row and vertical thing is called as column. We can describe like this only, but it is when it comes to technical terminology, we cannot explain like that. It will be better if we can give this specified information. Now, the intersection of row and column, whenever this row and column meets, that particular element is called as cell. In each cell, we can store only one particular value of that specified data type. When it comes to phone number, let us consider if it is of integer data type. In this specified cell, we can store only one integer value. These are the elements of a table. Table contains rows and columns. If we are arranging data properly in the format of rows and columns, it will be called as table. Now the question is, why do we need to store information first? For suppose, let us consider you purchased a bag from a store. You purchased a bag from a store, and this bag have it is given 1 year warranty, and there was some damage occurred for your bag within this particular 1 year, and you went to the shopkeeper to claim your warranty. How will shopkeeper find whether you purchased that bag in the same place within 1 year, or somewhere he must have some receipt, or somewhere he must have write it, or somewhere he must provided some bill for it. If he have some data or information related to it, then only he will be able to provide you the warranty. If there is no information related to your bag, how can you provide warranty for you stating that this bag is purchased within 1 year? It is not possible, right? That's why some information will be stored. It might be in the format of receipt or bill or something. In some format, information will be stored. The same information, if it is exceeding the capacities, for example, if it is a small store, all the items which they are selling, which comes under warranty, can be written in manual bills, and maximum they will get 1,000 or 2,000 bills per month, like that. Maybe they will get 1,000, or let us consider they will get 1,000 or 2,000 bills per month. Now, for per year, how many books they are maintaining? Let us consider one book will have thousand receipts or 1,000 records. Maybe they will, for each month, if they complete one book, for 12 months they will be having 12 different books. For suppose, let us consider if they are getting 1 lakh orders per day, 1 lakh orders which is related to warranty. These 1 lakh orders need to be considered under warranty per day. How can they provide receipts, and how can they resolve the? For example, let us consider these people have a lot of manforce and they are providing receipts manually for 1 lakh people. Let us consider 10,000 people came back to claim the warranty. How difficult it is to find that particular record which provided 10 days back. For example, 10 or 15 days back, or 6 months or 1 year back, they provided one particular receipt, and they want to check now whether this receipt is valid, or whether they provided that receipt or not. To cross check that particular record, it will take a lot of time and manual efforts again. This particular process will fail when it is exceeding, whenever the information capacity is exceeding. Then people started storing the information in computer once computer came into existence. First, it was on manual records. After manual records, they started having information in their computers. One of the initial data storing tool which was used is Excel. Excel is one such tool where they can store all these kind of information. And if they want to filter any particular record or any particular order, easily by using Excel, they were able to fulfill it. But when time is passing, this data size used to be increased very heavily. When it comes to Excel have some limited capacities. Even though Excel is capable of storing huge amount of data, Excel have some limitation. In Excel, for each sheet we can store only around 1 million records, around 10 lakh records only we can store in each sheet. For example, let us consider bank transactions. Let us consider we are storing some bank transactions in Excel. In India, on an average, more than 5 crore or 10 crore transactions will occur. Let us consider 5 crore transactions are occurring per day in India. How many Excel sheets do we need to store all these 5 crore transactions? In each Excel sheet, we can store only 10 lakh transactions. If I want to store 5 crore transactions, I need 50 sheets per day. Now, what about a year? 50 into 365. What about a decade into 10? How many Excel sheets do you need to store the data of 10 years? Even in the coming years, data size may increase gradually. Now, this became very challenging. For example, for 1 day's transactions, if you are having 50 different Excel sheets, one particular person came that my transaction got failed, end user didn't receive the amount, but money was deducted from my current balance. Now, how can a person check when in which sheet that particular transaction is present? Let us consider if there are 50 sheets per day, they have to navigate within all those 50 sheets and they have to provide information that this particular transaction is not failed or this particular transaction amount will be refunded. Some information need to be provided based on. But later on, a company called IBM introduced concept called database. First, they introduced the type of database called as IMS, Information Management System. We need not to worry about it. But just remember that IBM introduced or started storing data in the form of database first. Later on, it got developed to relational database. And in relational database, we have something called SQL. What is this particular database? Database is a storage container which allows you to store the information, to modify the information, to delete the information, and to automate the information. These are the things database can carry easily. When it comes to storage capacity, SQL doesn't have any fixed storage capacity. It will depend on your server storage, or it will depend on your laptop storage. It depends on storage of the device. It is not depending on storage, its own storage. When it comes to Excel, in each sheet we can store only 10 lakh records. But when it comes to SQL, even you can store 100 crore records in a single table. There is no such restriction. It always depends on the capability of your device. If your device is capable of storing 1 TB data, then you can use whole storage only to store information in SQL. There is no restriction in that. That's why people started using SQL. Any file of SQL will be stored with the extension called .sql. If any file ends with the extension called .sql, then it is called as a SQL file. Now, you might get a doubt call. There are a lot of tools which are available in the market. We have tools called MySQL, PLSQL, Microsoft SQL Server, Postgre. We have a lot of tools like this. Now, why we have so many tools? In all those tools, you are going to use only one specified language called SQL. SQL is the only language which will be used in all these tools. Let me give an example. Let us consider you have a movie which is downloaded, which is in .mp4 format. Video usually will be in MP4 format. Let us consider you have a movie in MP4 format. You have multiple mobile applications like MX player, VLC player, some other video players. Like that, you have a lot of applications in mobile. If you play this particular movie in MX player, is that movie going to change? If you play it in VLC player, is it going to change? If you play in some other video players, is it going to change? No. The movie will be same, whatever the tool which is used to play it. Even if the tool changes, movie will not be changed. Movie will be same based on your requirements or your flexibility or your interests on application, based on your likings on the user interface of the application. You can choose any one of these applications. Similarly, based on the comfort and everything, companies will choose their budgetings also. Sometimes these applications, these video players can have monthly prices. If you want MX player license, you have to pay 100 rupees per month like that. Based on that licenses, licensing cost or everything, these particular companies will choose any one of these tools. But ultimately, in all of these tools, language is going to be SQL. But there will be some difference in syntax because keywords vary from tool to. When it comes to MySQL, it will have a set of keywords. When it comes to PLSQL, set of keywords. Whatever I can say in a generalized way means 90% of the syntax will be same across the tools, but 10% will vary. However, the logic is not going to change between the tools. Maybe some of the keywords might change from tool to tool. Now, let us go to the concept. We are already aware that in SQL, we are going to store the information in the format of table and what is database and why we are storing information in database. We gathered all this information. Now, let me tell you how to store data in SQL. If you want to store any information in SQL or if you want to perform any operation in SQL, the first concept that you must be aware of is commands. When it comes to commands in SQL, there are 5 different types of commands. They are DDL, DML, DQL, TCL, and DCL. DDL means data definition language, DML means data manipulation language, DQL means data query language, TCL means transaction control language, and DCL means data control language. These are the 5 types of commanding language. By using these languages, we can pass instructions to SQL and we can perform any of the operations. These commands are nothing but of instructions. By using these instructions, you can pass any, if you want to create a table, you have a command called create. If you pass that particular command to SQL, it will create a table file. If you want to if you want to perform any of the operations in SQL, you have to use these commands. When it comes to commands in DDL, DDL deals with structure of database objects and DML deals with data present in table or values in table. DQL is deals with fetching the data, which is nothing but of printing the information. TCL deals with controlling the DML. If you want to control DML commands, for example, if you perform delete, if you want to undo it, then you can control it by using transaction control language. When it comes to DCL, here it deals with data governance, which means data access related things. Who need to get which access, which level of access. All this kind of information will be stored in DCL. When it comes to commands in DDL, we have create, alter, drop, truncate, and rename. In DDL, we have create, alter, drop, truncate, and rename. In DML, we have insert, update, and delete. In DML, we have insert, update, and delete. After that, in DQL, we have only one particular command called select. In the initial part of SQL, let us discuss about all these particular commands. When it comes to these particular commands, create is used to create the database or any of the database object. Let us consider if I want to create any database, I have to use query called create database. For example, if I want to create a database called students, create database students. If I execute this particular query, a new database will be created. A new database will be created. After that, after creating the database, this database will have lot of database objects. Table is the first database object which is present in database, which is used to store the information. Let us discuss about table here. In database, if you want to create table, if you want to create any of the database object, not only table, if you want to create any of the remaining database objects also, we have only one command called create. If you want to create something in SQL, then you have to use the command called SQL. Then you have to use the command called create. Now, if you want to create a table, then create table, table name. In between the parentheses, you have to provide all the column names along with their data types and constraints if required. And if you are providing multiple columns, you have to separate each column with comma. And you have to write the file. Now, this will be the syntax of writing a table, creating a table. Apologies, my handwriting is very bad as I am trying to give complete information very quickly. In this particular data types, when it comes to, we just listened about the terminology called data types and constraints. When it comes to data types, these data types are used to specify the kind of data, the type of data that you are going to store in a specified column, along with the storage capacity it requires. Type of data we are going to store, along with the storage required to store each value in that specified data type. Usually, we will have data in three different formats called number, text, date, and time. When it comes to number in SQL, we have two different categories. They are integers and fractional values or decimal values. When it comes to integers, again, based on the storage capacity of each data type, we have tiny int, small int, int, and big int. When it comes to tiny int can maximum store a value up to 255, small int around 32,000, int around 200 crores, big int can store a value up to 2 power 64 minus 1. These are the maximum capacities of each data type based on the column requirement. For example, if you are having a column called age is a column which, for example, you are in that specified column, you are storing the age of human beings. If you provide integer data type for age column, it doesn't make any sense. Integer can store a maximum value of up to 200 crores, even though it is capable of storing age value, integer will consume some additional storage when compared to remaining data. Usually in age, we will not find any person whose age is more than 255. That's why I can easily use tiny, which compares very less storage when compared to integer. Here, tiny int will usually use 1 byte storage, small int will use 4 bytes, integer will use 7 bytes, and big int will use 8 bytes. However, it is not that much required about storage capacity. Just be aware, like we will have four different data types in integer format based on the storage capacity and maximum value that we can store. We have to always choose from smaller one to bigger one. For example, if your value is exceeding 255, then you have to think about immediate next data type called small int. For example, there is a column called salary. In that salary column, I need to store salary of all the employees working in the organization. Salary can be more than 32,000, and mostly in most of the companies, salary will not be more than 200 crores per month, right? If it is the case, then for salary, I can use integer as data type. If I am storing age, then I will use int as data type. This is how we have to decide data type from lowest one to highest one based on the maximum value that we are going to store in that specified file. After that, we have fractional or decimal data types in number format. These fractional data types are used only whenever we are moving towards higher accuracy. If you need high accurate information, then we will go to fractional data type. Here we are going to store information after decimal point value. Here we have three different data types called float, double, and decimal. Here we have three different data types called float, double, and decimal. When it comes to float is a data type which can store 16-digit value where you have to include values before the decimal point and after the decimal point. Here we have to think about two different points called P and A, where P indicates precision, which means number of values we are storing before decimal point, and A indicates accuracy, where we will discuss about information that which is stored after the decimal point. P plus A, number of values that we are storing in precision, and number of digits that we are storing in accuracy should not increase 16 digits. If it is increasing 16 digits, then we will go to data type called double, which can store up to 32 digits. Double is nothing but of double the capacity of float. Here it can store up to 32 digits value before and after the decimal points. At last, we have a data type called decimal, which can also store 32 digits value, and decimal will not allow rounding. It will not allow rounding. If you want to round any value in decimal data type, we cannot do it. After that, we have text format of data. This text will accept both alphanumeric values. Alphanumeric values. Here in text, we have three different data types called character, varchar, and text itself as a data type. When it comes to character, character is a fixed length data type. And when it comes to varchar, it is a variable length data type. And when it comes to text, text is also a variable length data type. But the purpose of using text is when it comes to char can store maximum of 255 characters. Similarly, varchar also can store maximum of 255 characters in each cell. But when it comes to text, text can store any information up to 2 GB. Even if you want to store complete text from a book, we can store that information in text data type. When it comes to this fixed length and variable length, for example, if there is any value which is being stored in char data type column, for example, you provided char of 255 as the data type, and in that specified column, you provided a name called RAM. Similarly, in varchar also for one specified column called name, you provided data type called varchar of 255 and you provided a name called RAM. When it comes to char will consume storage for 255 characters as it is a fixed length data type. Even though you provided only 3-charactered word, it will take storage for all 255 characters. When it comes to varchar, it will assign the storage based on the value provided. Even though you provided varchar of 255 as the data type, it will take the storage based on the input value. As RAM is only a 3-charactered word, it will consume storage only for 3 characters. It will not consume more storage. But there is specified requirements if your data is regularly updating. For example, if text is uh, being increased its size and reducing its size based on the updates of the values. For example, Ram want to change his name as Ram Prasad. He want to update his name as Ram Prasad. Ram Prasad is a 10-charactered word which includes a space. Space also should be included as a character. It is a 10-charactered word. Now, if you want to update Ram as Ram Prasad, here in char already there is a fixed storage of 255 characters. You can store any number of characters up to 255. You can easily store the word called Ram Prasad. But in varchar, here basically by default, as you are giving input of 3 characters, it took only 3 characters storage. Now 10-charactered word will not be sufficient in 3 characters storage. Now what it need to do? First, it need to update the storage. After updating the storage, then it will update the value. Process will be difficult. When you have a column where data will be updated regularly, use character as data type. When you have any column where data will not be changed or data will be constant, then use varchar as data type. Let me give some examples. When it comes to varchar, you can use the column called gender. When it comes to char, if location can be changed, then you can use the column called location. Gender will not be changed regularly, right? That's why we can use varchar as data type for gender, and location for location we can use character. Remaining columns based on the requirement we can decide whether it requires character or word. After that, at last, there are three different data types in date and time format. They are date, time, and date time. Date is used to store information of the date in year, month, and day format, and time will store time value in hours, minutes, and seconds format, and date time will store both date and time together. When it comes to these text data types and date and time data types, while providing the values of these specified data types, always provide them in quotation marks. Always provide the values in quotation marks. This is about data types. Data types are used to decide the type of data that we are going to store in that specified column, along with the storage required for that specified column. After that, we all also discussed about constraints. When it comes to constraints are also called as restrictors, which are used to maintain business integrity. Business integrity or data integrity or cleanliness of the data. If you want to maintain data in your table cleanly, then we need to use constraints. These constraints are few of the conditions or restrictions. Only if data is satisfying these restrictions, it will allow the information into table. Here, when it comes to constraints, we have two different types of constraints. They are regular constraints and key constraints. When it comes to key is a unique identifier of a record. If any record is represented based on any value, for example, if the person information is represented based on his Aadhaar number, then Aadhaar number will be unique key for him. Similarly, if there is any PAN number or any passport number, whatever the number it might be, which is used to represent the information of the person, then it will become key value for that particular person. First, let us discuss about regular constraints. Here we have constraints called not null, default, and check. When it comes to null is used to represent unknown value in SQL. Null is used to represent unknown value in SQL. If you are providing a constraint called not null, it means you are not allowing any null values into that specified column, which means every value is mandatory. You can't leave any value as blank or unknown. If values in that specified column are mandatory, then we need to provide the constraint called not null. After that, default is a constraint which is used whenever we have same value repeated throughout the column. If same value is getting repeated throughout the column, instead of providing that value every time, like instead of typing that value manually, we can just provide a default value, and that default value will be considered automatically by SQL. After that, we have check constraint. Check is a conditional based constraint. We will provide a condition for a column. Only if that condition satisfies, it will allow the value into the table, or else it will throw the error that constraint failed. For example, if you want to allow people whose age is greater than 18, then you will create a check constraint with age greater than 80. These are the three different constraints we have in regular constraints. After that, in key constraints, we have unique, primary key, foreign key, and auto increment, auto underscore increment. When it comes to unique, the name itself defines that unique means different. This particular constraint makes sure that every value is different, which means it will not allow any duplicates, but it will allow one null value considering it as a new value or unique value. If you are providing list of values, for suppose at some point you received one null value, that one null value will be considered as a unique value and null value will be allowed into the column only for the very first time. Whenever you are trying to provide null value for the second time, it will consider that null is getting duplicated and it will not allow null for the second time. After that, we have primary key. Primary key is a combinational constraint. It is a combination of primary key is a combination of unique and not null. It is also called as a parent key, which can maintain referential integrity between multiple tables or relationship between multiple tables. Unique will not allow duplicates and not null will not allow even one null value. If you are having any secured information and if you are providing IDs for a secured column like Aadhaar ID or bank account number or any of the secured values, then we need to use primary key. We can use only one primary key for a table. We can use one primary key per table. And when it comes to foreign key is also called as a child key. By using primary key and foreign key, by establishing relationship between primary key and foreign key, we can perform referential integrity in SQL, or we can establish relationships between multiple tables in SQL. After that, at last, we have a constraint called auto increment, which is used to generate sequence of values. Auto increment is used to generate sequence of values one after another. For example, if you have 1 lakh values and if you need to have it one after another, you can have 1 lakh values and you need to have it one after another instead of entering them manually. Then you can go with auto increment, which is used to generate sequence of values one after another. Auto increment can generate sequence of values one after another without any limitation. Also remember that auto increment will work whenever that column contains constraint called unique or primary. Only if that column have the constraint called unique or primary key, then you can use the constraint called auto increment, or else we cannot use it. These are the concepts that you must be aware while creating a table. Let us consider you started creating a table. To create table, let's write a query to create a small student info table where you are storing some student information. To create table, we have command called create. table. Table name is student info. After that, in between the parentheses, I will provide few of the column names: student ID, student name, student location or location, and any other information if I need. Gender. After that, student ID, I am going to provide it as integer. If it is going to exceed 32,000, I am assuming that student count will increase more than 32,000 and I am providing it as integer. And I will also want the student ID to be unique and should not contain any null values. And also I am not going to allow duplicates. That's why I will provide primary key as a constraint. After that, student name, I will provide it as character, and I will provide the constraint called character of 20. I will provide the constraint called not null. Location, I will provide character of 20. I will provide default value as Bangalore. By default, it will take Bangalore as a value for all the locations. After that, gender, I will provide it as varchar of 10, and I can write a check constraint. Check gender can be male or gender equal to female. This will be the query to create a table. If I execute this particular query, table will be created. While creating a table, we will use all the information that we learned up to now. We will use commands. We are using a command called create. After that, we are using data types to specify what kind of data each column is going to carry and how much capacity does it require. We are using integer, character, and varchar. We are using multiple data types based on the requirement, and we are using few constraints to restrict the data cleanliness. If we want to maintain data cleanly based on the requirements, then we need to use some constraints which restrict and which maintain the data cleanly. Here I am using constraint called primary key not null default uncheck. This is how we can use all these concepts called commands, data types, and constraints together while creating a table.
Yeah, yeah,
We discussed up to creation of a table in C. After that, we discussed about DDL command, in which we discussed about only create command, which is used to create table. Also, we discussed about data types and constraints. Now, let us discuss about remaining DDL commands. They are alter, drop, truncate, and rename. For example, let us consider I created a student table where I have columns called student ID, student name, location, and gender. In this specified table, I want to add one more column called age. How can I add any new column to the table? If we want to add any new column to the table, then we need to use alt. Alter is a command which is used to modify the structure of any database. For example, let us consider structure of table in the sense empty table without any values. If you just create a table without inserting data, then there will be only empty table. If you want to modify anything in that specified empty table or skeleton or structure of the table, then we need to use alter. For example, let me write few of the actions or operations that we can do using alter. We can add a column, we can remove column, remove any existing column, we can change data type of a column, we can add a constraint to a column. Like this, we can perform these many operations using alter, and we can modify the structure of the table. If you want to add a new column, we can add a new column called age. If you want to remove any existing column, then we can remove any existing column. If you want to change the data type of the column, we can change it. Even if you want to add constraint, we can add. Let me write the syntax of alter to add a column. If you want to add a column to a table, the syntax will be alter table, table name. For example, my table name here is students table or student info. Add column, column name and its data type. We have to provide column name and data type of that specified column. For example, column name I am going to add is age and its data type is the name. For example, if you want to remove column, then we need to write drop column. For example, I want to remove the column called location. Drop column location. Location column will be alter table table name, drop column location. If you want to change data type of the column, then we need to use modify column. Alter table table name, modify column name. For example, for name column, you want to change the data type as varchar. Alter table table name, modify column, student name. I want to change the data type from char to varchar. I can provide varchar of 20. This is how we can perform any of the changes. Even if you want to add constraint, say in modify column, you can provide column name and you can add constraint as well. This is how alter works to modify the structure of database objects. After that, the next command in DDL is drop. Drop is used to remove database object from database and database from system. If you want to remove any of the database object, then you can remove the database object from the database. For example, if you want to remove table from the database, then you can just write drop table name. For example, let us consider if table name is students, here you need to provide students. If table name is product details, you have to provide product details. If you want to drop a view, drop view name. If you want to drop a stored procedure, drop stored procedure, stored procedure. If you want to drop a trigger, drop trigger name. For any database object, if you want to drop the database object, if you want to remove the database object from database, then you have to use the command called drop. Similarly, even if you want to remove database object from the system or server, then you can use drop database name. However, you drop database object. Similarly, we can drop database as well. If you want to understand the structure of this particular database object, let us consider this is the server or the storage container or a hard disk. In this particular storage, you are storing your database. Let us consider you are storing your database. This is hard disk. Consider this as a hard disk and this as the database. And inside the database, you will have database objects. It will be similarly like a folder in a folder in a folder, one within another. For example, if you are deleting a database object, let us consider it as a file which is present in a folder. If you delete a file, only the file will be deleted. If you delete database, the whole files which are present in the database will be deleted. This is how it will work. You can delete database object, which means file from database. Any database object you can remove from database using drop. Similarly, you can remove database from system, which means your hard disk or storage. This will perform the operation called deleting, but however, delete have some other functionality. I am using the terminology called remove here. If you want to delete something, then we need to use the command called drop. Like if you want to remove any database object or database, then we will use drop. After that, we have function called truncate. This truncate is we have command called truncate. This truncate is a command which is used to make table empty. It keeps the structure of table empty, which means it will remove all the values present in the table. Even if you have 10 million records and if you want to remove them in a single step, if you just truncate that particular table, then everything present in the table will be removed and table will become empty. It will remove all the values in a single step. After that, we have one more command called rename. If you want to change the name of any database object, then we can use rename. The syntax of rename is, for example, if you are renaming a table, we have to provide rename table old name to new name. Old name or current name, we have to provide the current name of the table. Two, we have to provide the new name for which you want to change. Rename table old name to new name. If you execute this specified query, table name will be changed to new name. From existing name, it will be changed to new name. Similarly, you can rename any of the database objects. However, it is not recommended to use rename in real time. Even though truncate is used only on mandatory requirements on surveillance, the same thing will be applicable for drop as well. Even if you drop the database, it is very difficult to recover it back. If you truncate the table, all the data in the table will be removed permanently. And if you want to get it back, if you have backup, only if you have backup, if you are using drop, truncate, or rename, then you will survive. If you don't have backup, then your data is gone. Even if you perform rename, everywhere wherever that specified table is called or wherever the table data is being used, in every place the table name need to be changed, or else the table data will not be fetched at the places where the old name is being used. That's why these three commands will not be used on regular basis. They are very high sensitive commands. These are the commands we have in DDL: create, alter, drop, truncate, and rename. After that, the next type of commands that we have in SQL are DML, which means data manipulation language. This data manipulation language works only on one particular database object called tables. This DML works on tables only. It deals with values or data present in the table. DML deals with values or data present in table. When you created a table, by default, table will be empty. If you want to add new data to the table, we have a command called insert. For example, if you want to add some rows to the table, then you need to insert those rows. If you want to modify or change any rows, modify any existing data present in the table, then you have command called update. At last, if you want to delete any records present in the table, then we have a command called delete. Insert is used to add records to the table. Here in SQL, if you are inserting the data will be inserted row by row. If you want to modify any existing value present in the table, then we can use update and similarly delete. While performing update or delete for the very first time, SQL will throw safety error, which indicates that if you update or delete the data in SQL, there might be chances of losing previous data if you are not using transaction control. To the purpose of this particular error, it just indicates the safety. If you want to proceed for the update, you need to execute SQL keyword called set SQL underscore safe underscore updates equal to 0. Here equal to 0 indicates the turning off. Here we need to turn off SQL safety updates. We will execute the query called set SQL safe updates equal to 0. After executing this query, we will proceed for update or delete. Here, when it comes to insert, if you want to insert any record into the table, just we need to use the syntax called insert into table name. After that, values. In parentheses, we need to provide values for all the columns present in the table in the same order. We need to provide values in the same order. For example, if you have columns called student ID, name, age, and gender, we need to provide values for all those four columns in the same order. We need to provide student ID number one. After that, name, let us consider Ram. After that, age 21, whatever the gender there, male or female, based on the value. Like this, we need to provide values in the same order. At a time, we can insert single row or multiple rows. If you want to insert multiple rows, you have to separate the each row with comma as separator after the parenthesis, and you have to open new parenthesis and you have to insert data for new record. Even we can insert multiple records at a time by having comma as separator, and we need to insert values for next row. We can insert n number of rows. There is no such limitation. We can insert n number of rows. This process of inserting data is called as implicit inserting. Here we will be inserting values for all the columns present in table. Let us consider we have information only for specified columns. We don't have information for all the columns present in the table. Let us consider I don't have age of few people. Then what do I need to do? I have to choose the option called explicit inserting. By using explicit insert, I can insert the data into the table. Insert into table name. After that, in parentheses, we need to provide the column names for which we need to insert the data. For example, you are inserting data only for student ID, name, and gender. You are not inserting data for age, values, and you need to provide values for all these three columns only in the same order. This process is called as explicit inserting. Whenever you are inserting data only for specified columns, it is called as explicit inserting. After that, we have update. Update is used to modify any existing value present in the table. For example, one person came that his name got misspelled, or there is some spelling mistake.
name and you want to modify it, you want to update. For example, student ID 1, Ram told that his name is misspelled and his clear name is Ram. He want to update that name to Ram. How can we change any existing value present in the table means we need to use the command called update. If we want to update the data present in the table, then we need to use the syntax called update table. For example, let us consider table name is students. Then we need to provide students here. Update table name, set column name. For which column you are modifying the data and what is the value you are updating. For example, for name column, you are updating the data. Here you need to provide name and here you need to provide the new value. For example, here I am changing the name as Ramu. I need to provide Ramu here. Updated value. And we need to provide where condition which is used to filter the data, which is used to specify the particular record after filtering the data. For example, for student ID 1, I need to change the data. In where class, we need to write condition. Based on this condition, only whenever this condition satisfies, it will update that specified information. This is how we can update the data which is present in the table. If we want to update any existing values which are present in the table, then we need to use update command. After that, we have one more command called delete, which is used to remove any existing records which are present in the table. If we want to delete any of the existing record, then we need to use delete from table name and we need to provide condition for which records we need to delete. We need to provide a condition in where class. Whenever this condition satisfies, this delete command performs deletion for those specified rows. It will remove those specified rows from the table. These three are the DML commands. When it comes to delete, this delete command works row by row and we can do undo if you are using delete. But if we are using truncate, we cannot do undo. By using transaction control language, if we are using delete, we can do undo. After that, the next type of commands is DQL, which means data query language. This data query language is used to print or fetch or retrieve the data. This data query language is used to print, fetch, or retrieve the data in SQL. Here we have only one command called select. Select is the only command which is available in DQL. This select command will help you to learn all the remaining database objects as well. Not only the table, you can work on views, stored procedures, functions, triggers. All these database objects will be depending on the command called select. Here in DQL, we will have multiple concepts again based on the requirement. They are normal query rating, basic select query. After that, we will have subquery. Sorry, we will have joins. After that, we will have subquery. After subquery, we will have derived tables. After derived tables, we will have common table expressions. These are the five different concepts we will have as a part of query writing. When it comes to first concept called query writing, it is used to print data only from single table. Whenever you are printing data from single table, then we will use query writing. If we are fetching data from multiple tables, then we will use joins. After that, if we have table dependency, which means if we are fetching data only from single table, but we are depending on another table to fetch that specified data, then we will use subquery. Whenever we are calculating nth highest values, nth highest value, we will use the concept called derived table. After that, whenever we want to perform some operation on the output of the query, for example, you wrote a query and you got some output for that specified query. On the output of the query, you need to perform some operation. Then we will use common table expression. Now let me explain you normal select query. If you want to print data from the table, you created it. If you have some table in the database and if you want to see whole data present in the table, then we need to execute the query called select star from table. You want to print data from the table, then we need to just execute select star from table. Here star indicates all the columns which are present in the table. If you want to print only specified columns, then we need to provide column names instead of, if you want to print only column 1 and column 2 from the table, then we need to provide select column 1, comma, column 2 from table name. It will print only these two specified columns from the table. When it comes to the complete syntax of the table, what are all the possible combinations that we can print from the table? We need to check the order of writing query. Here we will have classes called select, from, where, group by, having, order by, and limit. Order by and limit. Here, when it comes to select, select class is used to specify the columns that you are printing from the table. If you are printing all the columns from the table, then we will provide star. If we are printing only selected columns, or if we are printing only one or two columns, then we will specify those columns. Select class is used to specify the columns. After that, from class is used to mention from which table we are fetching those columns. For example, if you want to print these columns from table called products, then we will give select star from products. After that, where class is used to filter the data of any column which are present in table or base table. Filter the data of any column which is present in the base table. After that, we have group by class. Here, in where we will give the condition, and based on that condition, it will filter the data of the table. For example, if you want to print the data of the people only who are present in Bangalore, then we will give the condition like where location equal to Bangalore. Then from that table, it will filter the data of only Bangalore people and it will print only details of Bangalore people. After that, group by. This group by is used to group the data or divide the data into separate groups based on values present in the table. Groups data based on values present in the table. After that, having class. Having class is also, for example, when it comes to group by, let me give an example. Let us consider we have students from multiple locations in student table, and I need to group the data of each location student separately. All the students of Bangalore into a separate group, all the students of Hyderabad into a separate group, all the students of Chennai into a separate group, all the students of Pune into a separate, Delhi into a separate, Mumbai into a separate. This is how I need to divide data into separate groups. Then I will write group by location. Based on the values which are present in that location column, it will divide for each unique value, it will create a separate group. For example, all the data related to Mumbai will be considered as separate. All the data of Hyderabad will be considered as a separate group. It will group the data into multiple groups. After that, we have one more class called having. This having is also used to filter the data. It is used to filter the grouped data or aggregated data. Grouped data or aggregated data. We will use group by usually whenever we are performing some aggregation. If we are performing some aggregation, then only we will perform group by. And on the top of that aggregation, like for example, you got city-wise student count. And on the top of that aggregated data, if you want to filter the data, you want to fetch the data only where count of students is greater than 100. For example, in few cities, if count of students is less than 50, you don't want to consider that particular, you don't want to consider that particular location. So only wherever the student count is greater than 100, then only you need to consider the locations. Then we will use having count greater than 100. After that, we have order by class, which is used to sort the data in ascending or descending order. By default, SQL will sort the data in ascending. For example, if you want to sort the data based on name of the student, if you just provide order by name, by default, it will sort the data in ascending order based on name. If you want to sort the data in descending order, then you need to provide the keyword called DESC, order by column name descending. If you provide this keyword called DESC, it will sort the data in descending order, which means from highest value to lowest. After that, we have last class, which is called as limit. This limit class is used to restrict the number of records that we are printing. If we are printing only 5 records from the table, then we will provide limit 5. It will print only first 5 records in that specified order from the query. It will not print any of the remaining records. This is the complete order of writing query. We will write query like this in SQL, but SQL will execute this query in a different way. The order of execution will be from where group by having select order by and limit. This will be the order of execution of the query. First, SQL will go to the from class and it will go to the table. First, it will go to the table. After going to the table, it will check whether there is any where condition to filter the data of the table. Based on the where condition, it will filter the data. For example, there are 10 lakh records in the table, and after filtering, you have only 1 lakh records. That filtered data will present here. After applying the filter, it will check whether you are grouping the data and you are performing any aggregation. For example, after filtering the data, if you are performing group by based on any column, it will perform that grouping. After grouping the data, if you are performing again any filtration based on aggregated column, then that filtration will be happen based on the aggregated column. Finally, it will execute the select class where you will choose what are the required columns that you want to print. After selecting the columns, it will sort that particular columns, the data which is present in those specified columns in ascending or descending order. After sorting the output data, finally, if we want to restrict the number of records, we will use limit. For example, if you want to print first 100 records only, then we will use here instead of using top, I will use first 10 records. If you use limit 100, it will print only first 100 records. It will not print any of the next records. This is how we can print data only from single table by writing query by using all these classes in SQL. You should not mismatch the order of writing query. You cannot write group by class before where, you cannot write having before group by, or you cannot write order by after select. You cannot change the order of writing query. Order of writing query will be same. You have to follow the same order. Order of writing query will be same. After that, the next concept or next part of query writing is joins. This joins will be written in from class only. In from class only, we will be joining multiple tables. Whenever we are fetching data from multiple tables, then we will use joins. There are like few types of joins. There are inner joins, outer joins, and we have two other joins called self join and cross join. When it comes to inner join, we have only one keyword called join. When it comes to outer joins, we have keywords called left join and right join. If you want the output of full join, then we need to append left join and right join. Left join union, right join. When it comes to this inner join is used to fetch only matching records between both the tables. When it comes to join, while joining the tables, for example, let us consider you have table 1 and table. If you are joining table 1 and table 2, we will write this join in such a way, select after that columns that you want to print from both the tables along with the table name from table 1, or let us consider A as a table. From A, join B. Here I am joining table A with table B. After that, we will write on condition on A dot primary key equal to B dot foreign. They might not be definitely a primary key or foreign key, but if they are related columns, then we can use those columns in the we can use those columns to join those two tables. If we perform only join, then if there are matching values present in these two tables, for example, let us consider table A have values called 1, 1, 2, 2, 3. Table 2 have values called 1, 2, 2, 3, 3, 4. Now, if we are performing inner join, how many records will it return? Let us see. First matching record, second matching record, third matching record, fourth matching record, fifth matching record, sixth matching record, seventh matching record, and eighth matching. First, it will go to table A and it will search for any matching value which are present in table. One matching value. Again, it will go to second row. It will search for any matching value which is present in table B. Again, one value. It will go to third row. It will check for any matching value in table. There are two matching. It will go to fourth row. It will search for any matching value in table. Two records. Again, fifth row. It will search for any matching value in table. Two records. This is how total 8 records. If we perform only inner join, we will get 8 records. Let us consider here I have a value called 5 also. 5. Similarly, we have outer joins as well, where we have left join, right join, and full join. First, let us consider the keyword terminology, left join and right join. If we take left join, not only left, we have to use join also. If we take left join, it will fetch all the matching records. These 8 records are common. Let us consider A as left table and B as right table. This 8, all the matching records are common for left join and right. And when it comes to unmatched records, is there any record which is not matching with the value of table B, which is value called 5? There is one record which is not matching with any value of table. Then it will take one unmatched record as well. All matching records plus one unmatched record. Similarly, in the right table, if we use right join, it will fetch all the matching records plus unmatched records from the right table. Is there any unmatched value present in the right table? Yes, there is one unmatched value present in right table. For left join and right join, here we are going to get 9 records for both the joins. We will get matching records commonly for all the joins, and unmatched records will change based on the table. And if we need to perform full join, we need to use left join union right join. What this union condition will perform is it will append the data. It will try to add the second 9 records to the above 9 records, which means it will try to add left join to the right join. For example, while adding, what it will do means it will not allow duplicates. If you do left join union right join, first 8 records which are unmatched records will be taken. Sorry, which are matched records will be taken. After that, this one unmatched record will be taken. After that, whenever it tries to insert these 8 records for the second time, it will not insert because these are duplicate records. Whenever you are performing union, union will append the data without duplicates. It will not allow these 8 records and it will append this last one unmatched record. Totally, you will have 8 plus 1 plus 1. You will have 10 records if you perform full join. Full join will fetch all the matching records between both the tables, which are 8 records, plus unmatched records present in both the tables. In left table, we have one unmatched record, plus right table, we have one unmatched record. Totally, we will get 10 records in full join. After that, we have self join. Whenever we have self referential table, if the table is referring to itself, then we will use self join. Also, we have cross join, which is called as Cartesian product. Whenever you want to fetch all the possible combinations between both the tables, then we will use cross join. This is all about joins. If you are fetching information from multiple tables, then we need to use these joins. After that, the next concept which is available as a part of query writing is subquery. When it comes to subquery, here we will have nested query or query within another query. Here we will have two queries called outer query and inner query. Always in a subquery, inner query will execute first. In a subquery, inner query will execute first, and this inner query will be written in where or having classes. The subquery inner query will be written in where or having classes. And the output of inner query is used to filter the data of outer. Output of inner query is used to filter the data of outer query. We will use subquery whenever we got the requirement called table dependency. Here we will be fetching data, printing data only from one table, but we will be depending on some other table. Let me give an example. Let us consider we have two tables called products and orders. For example, here in products table, let us consider products table is a dimension table and the address is a fact table. And let us consider we have few other tables in the database like customers and all. But let us consider this products table and address table as of now. Here I have few product information. Let us consider I have product ID 1, soap and price of 20 rupees. Product ID number 2, pen which cost 2 rupees. Product ID number 3, pencil which costs 1. Like this, let us consider there are multiple products in product step and there are few orders like customer 1 purchased product ID number 2 and he purchased the quantity of 5. Like this, there is some orders still. In orders table, you will have information of which customer ordered which product, like who ordered which product and what is the quantity they ordered. All this information you have in orders table. All their sales information is present in orders table. Now, you want to find the information of the products which got sold. Only the products which got sold. There are few products which didn't get even single order. You want to avoid them and you want to fetch only the products which got sold. I just want products details. I don't want any information from others table. I just want products which got sold. Here I am fetching information only from products table. And to find which products got sold, I will be depending on orders table. In this kind of table dependency scenario, we will use concept called subquery. Also remember in the inner query of a subquery, we cannot use keywords called limit. We can not use some other additional keywords like some, etc. But the regularly using keyword called limit cannot be used in the inner query of a subquery. To overcome this, we can use the concept called derived table. In this derived table, inner query will be written in from class itself. Inner query will be written in where in subquery inner query will be written in where are having classes, but in derived table inner query will be written in from class itself. And we will write the query to fetch the nth highest values. If we want to fetch nth highest values, we will use the concept called derived table. And we have one more concept called common table expression, which will start with the keyword called with. With is a SQL keyword. With this particular keyword, we will start common table expression. We will write with and we will provide name for that common table expression with CTE name as and in parenthesis we will write the query with CTE name as and we will write the query. The output of this specified query will be temporarily stored with this common table expression. The output of the query will be temporarily stored with this specified name. After that, on the top of this output, by using this CTE name, we can perform any operation. We can perform update or delete or select or we can perform joins, whatever it might be. On the top of the output, we will be able to perform some transformation. Okay, after theoretical discussion, let us try to do everything practically. Let me try to create a database called student DB, where I'm going to store student related information in couple of tables. Let me create database. For creating database, we have a command called create. As I'm creating database, I have to use the keyword called database. Create database. I have to provide database name. I am giving database name as student D or student underscore. So providing the name for database, just click on control enter to execute the query, or else you can select the query and click on the thunder icon which is available at the either of the things, anything you can follow, but it is easier to follow clicking on control enter. After creating the database, if we refresh the schemas, the database that we created will appear somewhere. And to use that specified database that we created, we have to use the keyword called use, and we have to provide database use student underscore. Name. If we execute use database name, that specified database will be selected. Selected database name will appear in bold letters. All the remaining database names will appear in normal text, whereas selected database name will appear in bold letters. If you are using MySQL as your application, you can double tap on any database name so that the database will be selected. If we select on the double tap on any database, it will be selected in MySQL. Maybe all other SQL tools might not have this feature, but this keyword called use database name will work. After creating the database, we will be able to see the list of database objects it contains. Let us discuss about the major database object called tables. To create tables in SQL, we have to use the command called create only. For creating database or database objects, we have to use create. For creating tables, create table, table name, I'm providing as student details, create table, table name. After that, in between the parentheses, I will provide complete information of the students along with the course ID they can have. Before creating the students details, let me create one more table which contains the course information. Create table, course details, create table, course details. After that, in between parentheses, I will provide course related information. Here I can have course ID, course name, and just consider these are the information I'm storing in course details table. When it comes to course ID, I will take it as the name and it is a primary key. After that, I will have course name. Course name can be character of 20 and provide a course name as character of 20. If required, I can provide constant called normal as well. After that, C I am providing as integer or small. based on that requirement, small it. After that, let me execute this query. Now the table got created with the name of course details. To print this particular table, I need to use the query called select, which is part of DQL commands. Select star from course details. If I execute this query, I will be able to get course details table. As of now, as I don't have any values, I will be able to get the skeleton of the table, which means empty table with letters or columns. Now, if I want to modify the structure of this table, for example, if I want to add one more column, or if I want to remove any of the existing column, then I can just use the command called alter. Alter is a command which is used to modify the structure of database object. Either it might be table or any other database objects. If you want to modify its structure, then you have to use the command called alter. For example, if you want to modify the structure of the table, let us consider in my requirement, I want to add one more column called duration, where I store the value, how long this course will, will be. Like I want to add one more column called duration. To add that column, I will just alter table course details, alter table course details. For adding column, I need to use the keyword called column, add column. We have to provide column name along with its data type. Duration, duration. If required in bracket, I can provide something, whether it can be days or, for example, duration underscore days. Or duration in days, or else if required, I can provide just as duration or based on the requirement, you can just a column name, duration, and I will provide it as small. Till if I execute this query, one more column called duration will be added to course details table. If I execute this course details, now I will have four different columns. After that, we have few other commands. For example, if I want to remove all the values present in this table, then I can use truncate. Before that, first let me insert few values into the table. If you want to insert data into the table, we have DML command called insert. The syntax for inserting values into the table is insert into table name, insert into course details, insert into course details, values. After that, we need to provide values for all the columns present in the table in the same. Either we can insert single record or multiple record for the same. Course ID, course name, fee, duration. Like this, I can have values for all the columns for a row. And after completing one column, if we want, after completing values for one row, if you want to insert information for multiple rows at the same time, you can just copy the thing and with comma as separator, we can insert multiple records at the same time. Post ID number 2 and taking as Power BI and duration is 5. This is how we can provide multiple values into the table at the same time using insert by using comma as separate. After that, if We just click on Control Enter after the end of the query. Both the values will be inserted into the table. If I execute select star from course details, I will have both the records. Now, if I want to remove all the records present in the table at the same time, either it might be one record or 1 million records. If you want to remove all the records present in the table at the same time and you want your empty table back, which means the skeleton of the, then we need to use the command called truncate. Truncate table. If you provide truncate table name, it will remove all the values present in the table. If we execute select star from course details again, both the records which are inserted will be removed at the same time in single step. If you want to remove table itself completely, not only the values present in the table, if you want entire table to be removed permanently, then we need to use the command called drop. If you want to drop the table, if you want to remove table completely from database, we have to use drop table. Not only for table, this will be applicable for remaining database subjects. If you are dropping the view, then you have to use drop view name. If you are dropping the stored procedure, drop stored procedure, stored procedure. This is how it will work. Drop table name is course. We execute this query, table will be completely removed from the database. If you execute select star from course details, it will throw the error stating table doesn't exist. If you see here, student underscore DB in this specified database, course detail table doesn't exist. This is how it will throw the error after dropping the table. If you drop the table, it will remove table from database. And if you try to print the table again, it will throw error stating that table doesn't exist in that database. Let me recreate everything like I remove the table and that. Let me create them. I created course details table once again. So I execute course details table. I will get three columns which I created initially. After that, let me add the duration column as well. Okay, now I have all the four columns. Let me set the values. Now I have my table back. I hope you understood the truncate and drop commands. Truncate is used to remove all the values present in the table, whereas drop is used to remove the table. It won't even leave the skeleton or empty structure of the table. It will remove the table completely. After that, let me create one more table called student details, where I have information about students. And let me have one foreign key column called course ID, which refers to course which is enrolled by the student. For example, let us have student ID. Here we have columns called student ID, which is small int. And if you want student ID to be unique, we can have it as primary key, or if it contains duplicates, then we can leave it normally. Student ID, student name, I can have character of 20. After student name, I want detailed location, where care of 20. We can decide the data type which we need to provide, so that if we want to take gender, I can have where care of 20. After that, at last, I will have course. This course ID will refer to the column which is present in course details table, which refers to course ID column which is present in course details table. This is the foreign key. Mention that it is foreign key. I need to write foreign key, foreign key course ID, foreign key course ID, refer references, foreign key course ID references, course details of course ID. We have to provide its primary key column, its parent column, for which column it is referring. Course details of course. After that, if you execute this particular query, student details table will be created. If we execute select star from student details, select star from student details. Here we have student details table. Now let us try to insert few values into student details table. After that, we can write queries on the top of this course details and student. So insert into student details, values. After that, we need to provide values for all the columns present in the table in the same order. I have student ID number one, name, Ram, location Bangalore, location Bangalore, gender male. After that, course ID and also course ID. Let me have multiple records with student details by using comma separator. Let me insert few other values. Okay, let me insert this student information by modifying the values. After completion of each record in between the parentheses, we have separate the record with. We need not to provide comma for the last. Let us assume few students enroll for few different courses and let me click on Control Enter to execute the query. Now I have student information and student details table. If I execute select star from student details, I have information of 8 different students who enroll for the corresponding courses. Now, if I want to update the information of any person, for example, student ID number 7% want his name to be Sai. His full name is Sai Kumar. By mistake, he provided only Sai. He want to change his name to Sai. If somebody want to modify any existing value which is already present in the table, or if you want to change the value which is present in the table, then we need to use the command called update. Update is a DML command which is used to modify any existing value present in the table. Let me execute the query. Update student details. Update student details. Set name equal to Sai Kumar. After that, we need to provide the condition to filter the data for whom we need to modify the value. For example, here I need to modify the value for student ID 7%. I will provide the condition called where student ID equal to 7. If I provide this where condition will filter the data which is present in the table. And after filtering the data, only for the records which satisfy the condition, it will update the value. Here, student ID 7 have only one specified record. For this particular record, it will change the name to site. If I execute this query for the first time, as you know already, for the first time, whenever we execute update or delete in the database, we will get safe update mode error. You are using safe update and you try to update a table without uh, security features. Like if we try to update or delete the data from the table, it will automatically throw this error. To turn off this particular feature, we need to execute set SQL underscore safe underscore updates equal to 0. Set SQL safe updates equal to 0. If we execute this particular keyword, safety updates will be turned off. Equal to 0 is used to turn off and equal to 1 is used to turn on. Here I am turning off. If I execute this particular query, safety updates will be turned off. And if you execute this update query now, it will be executed successfully. Now if we execute select star from student details, for student ID 7, name will be Sai. Okay, after that, we have a command called delete, which is used to remove the records from the table. If you want to delete the information of any specified student, for example, if you want to remove the information of student ID number 8, then you can delete that particular record by using delete command. By using delete, either we can delete single record or multiple records. Here I am trying to delete one record. Delete from student details. Delete from student details where student ID equal to delete from student details where student ID equal to. If I execute this query, student ID person 8 details will be removed from the table. If I execute select star from student details, I will have only 7 records. Student ID person 8 details will be removed from the table. By using delete, we can remove the information from. In DDL, we have commands called create, alter, drop, truncate, and rename. We tried create, alter, drop, and truncate, whereas the rename is used to modify the name of any table. If you want to change the name of table or any other database objects, then we can use rename. Uh, in DML, we have commands called insert, update, and delete. We tried all these three commands. We inserted data into the table. We after that we updated some existing value which is present in the table, and also we tried to delete one of the value from the table. Now, after that, let us go through next concept called query writing, which comes under DQL. Here we will discuss about multiple concepts called query writing, joins, subquery, derived table, and common table expression. First, let me complete normal query writing, which contains components called or classes called select, from, where, group by, having, order by, and name. If you want to print complete information from the table, we can just execute select star from table. For example, if I just execute select star from student details, it will execute complete table and it will print the complete table as it is, which is available. It is printing the complete table. If we want to apply any filter on the top of this student details table, for example, I want information of the people who enrolled for course ID number one only. Then I can just use where class. This where class is used to filter the data of any column which is present in the table. Only if that specified column is present in the table, then we can filter that information using where. For example, I want information of course ID number, where course ID equal to 1. If I execute this query, it will filter the information of the students who enrolled for course ID number. There are 4 students who enrolled for course ID number. Now, after that, we have group vectors. Let us consider if we need to perform some aggregation instead of printing complete table. Let us consider I want to find the count of students. Count of students who enrolled for course ID. Here I want to perform the aggregation called count is. I will just write select count of stars from student details where course ID equal to 1. Now this query will return me only count value. It will not return any of the columns from the table. It will just return the count of records which are present in the table. Here in this specified table for course ID number one, I have 4 records. It should return the count card. You see, it is returning the count card. So now here I want count of students based on their gender. How many male students are there? How many female students are there? I want to get complete information. For that, if we have only few categories like Here I have only two categories called male and female. For suppose if you want location wise student count and there are 300 or 400 locations. If we have only two or three categories, then we can write in where class itself. You can also write multiple conditions in where class where you can write where location equal to Chennai or where gender equal to male and where gender equal to female. Like that, you can write multiple queries and you can get count separate. If you have 300 or 400 locations, for each location, if you are calculating the count for each location separately, it will not make any sense. It requires 300 separate queries and you need to execute all the 300 separate queries separate. Instead of that, we have a class called group by, which is used to group the data, which is used to divide the data into separate sets or separate groups based on the values present in the column. For example, if you want to do group by based on location, if you just provide group by location, it will perform aggregation for each location separately and it will provide the output separately for each location. For example, if I want to get aggregate based on gender, group by gender, if I execute this query, I have four students, two students were male candidates and two of them were female. If I execute this query, I will get two and two. Now, here I have a confusion. For example, as there are two candidates for each gender. Now, if you can consider first value as male or second value as male, it doesn't make any difference. But if you have different values for each gender, or let us consider you are calculating based on location, student count based on location. You have 300 locations and each location contain different value. How to find which value belonging to which location? Then whenever you are using group by, make sure that group to column should be provided immediately after select. As you are grouping based on gender column need to be provided immediately after select. If we execute the query now, it will give there are two male candidates and two female candidates. This is how group by divides the information into separate groups and performs the aggregation for each group separately. After group by, we have next class called having. Having is used to filter the data of an aggregated. For example, here we have a column called count of students. Let me rename this column as student. Let me review the query once again. See, I have gender and student count. The student count column is not present in base table. We don't have this column in student details table. If I execute select star from student details, I will not have the column called student because it is an aggregated column. This column I am getting from the aggregation called count of students. If you want to filter the information of any aggregated column, then we need to use the class called have. For example, if I want to find the gender where student count is greater than 2, which means only when student count is starting from 3, I want to get that gender information. For both male and female, student count is less than or equal to 2 only. For both male and female, it is equal to 2 only. It is not greater than 2. Then it should not return any records. Let me show you. Having student count, having student count greater than, if I provide greater than 2, it should not return any records. If I execute the query, it will return the blank table because for both the records, student count is 2. It is not greater than. If I provide greater than equal to 2, if I execute the query now, it should provide the information because student count is equal to equal to 2 will be satisfied. If I provide greater than equal to After that, order by is used to sort the data based on any column which is present in the table. Here in the output, as I have these two columns called gender and student count, let me sort the data based on gender. So I provide order by gender in alphabetical order. It will sort the data in ascending order. If I execute this query, female value is coming first and male is coming. Female. If we want to sort in descending order, we need to provide the keyword called descending DESC, which is used to sort the data in descending order, which will become vice versa. If we execute this query, first male value will come, after that female value. After that, we have limit, which is used to limit the number of records that we are printing. Here I am printing two records. If I want to limit it only for one record, then I can provide limit one. And if I execute the query, it will print only the first record. It will not print the next. This is the complete query details. Here we have classes called select from, where, print by, having, order by, and when it comes to order of execution of the query, first it will go to the table in from class. First from will be executed. After that, it will filter the data. After that, it will group the data. If there is any aggregation performed, it will filter the aggregated column. After that, it will go to select and it will print all the remaining columns. At last, it will perform order by and limit. From where, group by, having, select, order by, and limit. This will be the order of execution of the query. This is all about query writing in SQL. After that, if you want to fetch the information from multiple tables, let us consider here I have student details. I want information of the courses for which each student enrolled. Then, if you want to fetch data from multiple tables, we have to use the concept called joins. Okay. If we want to fetch information from multiple tables, we have to use the concept called joins. When it comes to joins in SQL, there are multiple types of joins called inner join and outer joins. In inner join, we have only keyword called join, which is used to fetch only matching records between both the tables. If there are any unmatched records, those information will not be fetched. When it comes to outer joins, there are two types of joins called left join and right join. This left join is used to fetch all the matching records plus unmatched records from left hand. When it comes to matching records are common in all the joins plus unmatched records from left hand. Similarly, right join will fetch all the matching records plus unmatched records from right hand. If we want to write join between if we want to join multiple tables, we have to join these tables in from class one. In from class of select query, we can join multiple tables. Let me write the query. Select current requirement for me is I want to get all the student details along with the courses they enrolled. Select star from student details. Select star from student details. Join course details. Course details. Let me rename the student details as yes, and course details as C. And we need to provide based on which column are we going to join these two tables. If we are joining multiple tables, there must be a matching column between these two tables. While providing student details table, we created a column called course ID, which is referring to column which is present in course details table, course ID column which is present in course details. These two columns are related to each other. In course details table, course ID is the parent column, which is a primary key. And in student details table, course ID is child column, which is foreign. As there is relationship between these two columns, then we can provide these two columns in on condition. This on condition is used to match the data between both the tables. On yes dot course ID is equal to C dot. Let's see. So that if I execute this query, I will get complete information of the students along with the course they enrolled for. Here, if you see, I will get all the 7 records, the students along with the courses they enrolled for. Here, by default, it is sorting the information based on course ID column. But if you want to sort the information based on student ID, we can just provide order by student ID. By default, it will sort in ascending order. If we execute the query, it will sort the data information sorting with student ID. Here I used normal inner join, which will fetch only matching information between both the tables. As of now, I don't have any unmatched record between student details and course details because I have two courses, and out of 7 students, few of them enroll for first course and few of them enroll for second course. Let me add few more courses called course ID number 3, which is called data analysis, which runs for 70 days, and course ID number 4, which is artificial intelligence, which runs for surface. If I execute this query, okay, here I think I provided data type false null. If I execute this record, this query, both the records will be accepted. If I execute select star for course details, now I have four courses, and students enrolled for only two courses called course ID 1 and course ID 2. Course ID 3 and 4 are unmatched because there were no student enrolled for course ID 3 and 4. Now, if I want to get the unmatched records as well, we want to go to the outer joins. When it comes to left join will fetch all the matching records and unmatched records from left side table. When we take the keyword called join, the table which is present in the left hand side of the keyword called join is called as left table. And table which is present in the right hand side of the keyword called join is called as right table. If I perform left join, it will fetch all the matching records and unmatched records from student details table. In student details table, I have information based on course ID 1 and 2 only. I don't have any unmatched records. But let me give the left join file. It should fetch only, it will return all the matching records with it. Which means it should return the same output as inner join. If I execute this query, I will get the same output as inner join. I will get the same 7 replies. Now, if I want the unmatched records also, I want unmatched records which are related to course information. For course ID 3 and 4, I don't have any courses, any student, right? Those are unmatched records. If I want a unmatched record information also, I need to use right join. Here, right table is course details table, right side table is course details table, which contain matched records. If I execute this query, I will get 9 records. See, 7 student records and 2 records where I have only course details information. I don't have student related information. Also, we have full join as well, which doesn't have any direct keyword. But if we want the output of the full join, which means if we want all the matching records plus unmatched records from both left and right tables, then we need to write both left join query and right join query. In between left join and right join, we need to perform the operation called union. This union is used to append the data. Here I wrote order by. Let me union is used to append the data of two tables. Like this, but first query of the left join will return some table as the output. It will append the data to the second table. It means it will add the rows of first table output to the second table output. Whenever you are performing union, it will not allow duplicates. For example, first it will take the left join output, where you will have all the matching records and unmatched records plus unmatched records from left table. Again, whenever you are adding the records of right join, where you will have matching records plus unmatched records from right table. As you have already matching records present in the previous query, it will not allow duplicates, which means it will not allow matching records for the second time. It will add only unmatched records from right table. Then you will get the complete output of full. You will get all the matching records, unmatched records of left table, plus unmatched records of right table, because it will not allow matching records for the second time, which were duplicate values. Union will not allow duplicates. If we execute this query, I will get the same output as right join because as I don't have any unmatched records in left table. Okay, we have two more joins called cross join and self join. When it comes to cross join is also called as Cartesian product. Whenever we want to get all the possible combinations between both the tables. Let us consider we have table 1 and table 2, which is course details and student details. If student ID one person enrolled for all the courses, how many combinations it can have? I have 4 courses and one student. I can get 4 different combinations. If I have 2 students and 4 courses, totally I can have 8 different combinations between them. It is also called as Cartesian product because the number of records that we are going to get in output is equal to the product of number of records in table 1 and table. If you multiply number of records in table 1 with table 2, those many records we will get in the output of cross check. The syntax is very easy. Just we need to write select star from table 1 comma table like student details comma course details. If we just execute select star from student details comma course details, it will return all the possible combinations between both the tables. As of now, for me, it is returning 28 rows. You can see that 28 rows were returned. Because in student details table, I have 7 records, and course details table, I have 4 records. Totally, it is returning me 28 records. We also have self join, which we will use rarely, which doesn't have any keyword. We can use any of the joins like inner join, left join, or right join. syntax only, but we will use the self join whenever we have self referential name. If we have primary key and foreign key in the sense both the matching records in the same table, and if it requires to join same table with itself, then we will call that join as self join, but we don't have any separate syntax or keyword for self join. We can use any of the above joins. This is how whenever we are fetching information from multiple tables, if we have data in two or more than two tables, then we will perform join between those tables. At maximum, we can join 256 tables in SQL. We cannot perform joins more than 256 tables. Okay, let me give you some other requirement. Now, I want the details of the courses for which no student were. I want information of the courses for which most students got. For example, I have four different courses. I am providing four different courses. Out of those four courses, I got students only for two courses. Remaining two courses, I didn't get any students. As I am not getting students, maybe I can plan to discontinue those courses, or if I want to promote those courses, I can make decision based on. If I want to find the details of the courses where no students were enrolled, then I need to perform sub. Here, I need the details of courses only. I don't want any information of the students. I want the details of the courses where students didn't enroll, for which course student didn't enroll. Now, if I want the information of the courses for which no student got enrolled, as I am fetching information only from one table, but I am depending on another table. Here I am printing data only from course details. I'm not printing even single column from student details. But I will be depending on student details table to understand for which courses students enrolled for and for which students they didn't enroll. Only in student details table, based on course ID, I will be able to find for which courses students enrolled for. Based on that, if I perform not equal to operator, I will be able to get for which courses student didn't enroll. Let me write the query. Here in a subquery, there will be two different queries which are called as outer query and inner. When it comes to this outer query and inner query always executes first. We have outer query and inner query. Here, inner query will always execute first and it will help to filter the data of outer query. Let us see how it will work. It is also called as nested query. Let me write select star from course details where course ID not in. Here I am not using the operator called in. In is used to filter the matching values. Here I am using not in because I want the courses which were not enrolled by the students. Select now here in the inner query, I want to write the query to find distinct of, which means unique values of course IDs which were enrolled by the students. Select distinct of course ID from student units. Okay, here, what will this inner query terms? Inner query will return me distinct of courses which were enrolled by the students. Now, I am writing query to find the course details where course IDs are not present in 1 and 2. If course IDs are not 1 and 2, not in 1 and 2, if they are except 1 and 2, if they are any other values than 1 and 2, then I want to return those course details information. If I execute select star from course details, where course ID not in, and I'm writing this query as inner query, this query will return the values called 1, comma 2, and as inner query in a subquery will execute first. This inner query will get executed, and the output of inner query will present in here, which means in this scenario, the values called 1 and 2 will present here, and it will execute the query called select star from course details, where course ID not in 1 comma, which means if course ID is any other value beyond 1 and 2, will return those details. By using this query, I will get the information of the courses where no student got enrolled. This is how we can perform subquery. Let me execute select star from student. I executed the query. Or let me execute select star from course. Select star from course. Here I have four different courses. Let me update the fee of four different courses into four different values. Update course details. Set fee equal to 14 over where course ID equal to. Now I have three different values. Similarly, let me update for course ID number 4. For course ID number 4, A, I'm changing course yes. Different value. Now I have four different values. I have four different values. Now, here my requirement is I want to find the nth highest value. Now, here I want to find second highest value in the fee. Second highest value in the fees. Here I have four different values. First highest is 25,000. Second highest is 24,000. Third highest is 15,000, and fourth highest is 40,000. I want to write a query to find the second highest fee value. So I want to find the second highest value. Then let us try to solve this requirement by using a subquery first. First, let me write a query to find the highest value. To find the highest value, I will use the function called max, which will return the maximum value from the column. Select max of fee from performance. Select max of fee from performance. If I execute this query, I will get the first highest value, which is nothing but of maximum. Here the maximum value which is present in course details list 25. Maximum fee which is present in post details tables 25. If I want to find the second highest value, what can I do? Is I can write one more file where I can write select max of fee from course details, where fee less than select max of fee from course details, where fee less than the highest previous query is used to fetch the highest fee value, which is nothing but the first highest one. If here in the second query, I am writing query to fetch the highest value, which is less than first highest value. What will be the highest value which is less than first highest? First, always here I am writing the inner query in where class. Always remember that in subquery, inner query will be written in where or having class, which is used to filter the data of outer. Here, as I am writing subquery, always inner query will be executed first. This inner query will execute first, and here it will return the value called 25,000, which is the maximum value of fee in course details step. After finding the value called 25,000, after fetching the value called 25,000, it will try to execute the outer query. In outer query, first it will execute which class. Always while executing the query, order of executing query will be first it will be execute from class. First it will go to course details study. After that, what it will come? It will try to filter that. After from it will execute where it will go to air class. It will filter the records only where fee is less than 25,000, which means it will filter remaining three records. It will have records of 24,000, 15,000, and 14. Out of these three records, I'm trying to fetch the maximum, which will return me 24,000. If I execute this query, it will return me 24,000. Now, for example, if I want to here with this query, I'm able to fetch the second highest value. If I want to fetch third highest one, what can I do? Again, I can write the same query less than where fee select max of fee from course details, where fee less than first two highest. Here, these two queries will return the second highest value. After that, if it is max of fee, which is less than second highest value, will become the third highest. If I execute this query, it will return third highest. For example, if I want 50th highest value, I can't write 50 inner queries one inside the another, right? Like it is very difficult to write say 50 nested queries, and it will take a lot of time to execute it. It will reduce the performance of the query. That's why what I will do is instead of writing like this, I will I will take a different up. First, let me write a query. Here I will try to fetch the fourth highest value like that. Let me write a query to find top four C values. Select distinct of C. Select distinct of C from select distinct of C from course details. Order by C descending. I'm trying to fetch fee details from highest value to lowest value. Limit 4. Limit 4. If I execute this particular query, it will return me all the four fee values from highest to least in descending. Now, as I have top four values, if I want to fetch the fourth highest value, or if I want to fetch third highest value, let me take fourth highest. If I want to fetch fourth highest value, if I fetch minimum value out of top four, is it easy to fetch fourth highest value? Let me write the query. to fetch the minimum of top four. Select minimum of C from course details where C in select min of C from course details where C in, and I will write this as inner. First, it will execute the inner query. It will fetch top four highest fee values. Out of top four, I am finding to fetch the minimum value. Out of top four, minimum value will be the fourth highest value. But if I execute this query, I will get the error because in a subquery, in the inner query, we can't use in the inner query of the subquery, we can't use limit. That's why what I need to do is here always in a subquery, inner query will be written in where are having clauses. Instead of writing this where are inner query in where are having clauses, this inner query will be written in from class itself. Select min of C from select min of C from in from class itself. I will write this inner query. Even though the query is correct, if I execute this particular query, even though the logic is correct, it will throw the error because whenever we are writing inner query in from class, we have to provide an alias name for the inner as top four values. I am providing name as top where I have top four C values. Here, what will happen means here also inner query will execute first. Inner query output, the output of inner query will be fetched as a separate table. The output of inner query will be fetched as a separate table. If I execute this query now, I will get minimum of C details from top four. From top four, the minimum value will be the fourth highest. If we want to find the nth highest value in SQL, then we need to follow the approach called derived, where we will write the inner query from class. After that, we have one more last concept in query writing, which is nothing but of common table expression. Common table expression. This common table expressions are used whenever we want to perform any additional operation on the top of query. For example, here I have a query which returns the course details which were not enrolled by any of the students. No student enrolled these two courses. Then if I want to do some modification for these two courses, then what I can do, I can perform common table expressions. What I will do, the syntax for writing common table expressions, first we need to use the keyword called with. After that, we need to provide some name for the CTE with no enrollments as with no enrollments as. After that, in between the parentheses, we need to write the query that we want it with no enrollments as. After that, I wrote the query. After that, on the top of this query, on the top of this query, if I want to execute something, for example, what will happen here is the output of this query, complete query will be stored with the name of this CT. Now, if I just execute select star from no enrollments. So I just execute select star from no enrollments. It will return the same because in no enrollments CTE, the output of this query got stored. Even not only the select query, if you want to perform even any other operations, if you want to perform update or delete or any other operation, you can perform on the CTE. If I just execute this CTE called no enrollments, you will be able to get the same output of the courses where there were no enrollments because the output of this select query was temporarily stored in this common table expression called no enrollments. This common table expression is used if you want to perform some operation on the top of the output of select. For example, here, instead of printing the data, if you want to update the fee information or something for this specified output, then you can perform update query for common table expression called no enroll. No enrollments. If you update data present in no enrollments, then the same update will be implemented for these types. This is how common table expression.